Today we are going to do section 6.6. It is a very important section, okay? We're going to do exponential and logarithmic equations. Now the equations in general are very important in algebra and beyond. So it's the equations are taught in section 2.2 and 2.6 of this book. Now if you feel like you're feeling any discomfort with solving equations, please review those sections. I also have this written down in the video description. Okay, reviews how to, if necessary, solving equations, which is section 2.2 examples 1 to 7 and 2.6 examples 1 to 11. Just redo those examples if you're not comfortable with solving equations, and then see how and if you have trouble, the book shows you how it was done. And of course, I also have videos of those made already. So please be sure that you know how to solve equations, okay? And then this section will come very nicely. So before we start this section, I want to mention, let's review what we have learned about logarithm so far. The definition of logarithm, it comes from exponents. That is, if b to the power x equal to y, we say the log by equal to x. These two statements mean the exact same thing. Okay, that is, so in other words, log by means b to what power equals to y, and that's the logarithmic function's meaning. So these two, this describes the meaning of that. Now, to do that, then of course we have this interesting situation. If x equal to log b of y, okay, this is x, means the b to the power log by, which is x, right? Is going to be equal to y. We're repeating this formula right here. That is b to the power log by, being that it is x, that it will be equal to y. And another way of saying is b to the x power equals to b to the x here, which means log b of b. That is, if you have two b's at the same time, that means this logarithm will just be equal to x, because logarithm means b to what power equal to what's inside, and b to the x power will be equal to b to the x power. See, so these are also equivalent statements of this. Okay, so anytime you see b and then log to the b, so they're repeat of b's here, and then that value is just equal to y. Whatever is here is going to be this whole value. See, similarly, b to the, if you have two base here, then the logarithm with an x on top end up just being x. So these are these are repeats of other ways of saying these two sentences. And then we have learned certain parts, right? We learned that the product becomes sum. Okay, you can split it out into sum. Similarly, division becomes subtraction, and then any kind of power you can kick it in front. Okay, and then this isn't used as much, but you bear in mind that if you log a base of some number, that can be used some other log. In this case, I used the natural log of this number divided by the natural log divided by the base, and this is in the same as this one in the case when x equal to 1. That's if you have a log b of b. Okay, where x equal to 1, then it just equals to 1. All right, and the next thing I want to quickly review, this is the exponent rule, okay? When you have two products multiplied together, the same base, right, then the exponents will add up. Now this applies even if one of them is negative. Like say if y is negative, then this will be x plus a negative number, which is the same as dividing, okay? So, yeah, the negative, y is a negative, which is the same as subtracting. So the negative equation is included in this concept. That is, whether y is positive or negative, yeah, when you have these two powers multiplied together, that's with the same base, that's the same as adding up the exponents. And next, here's another rule, is that if you have an exponent and then the whole thing is raised to a different exponent or the same, doesn't matter, another exponent, different or the same, then you end up being multiplied together. And this is in exponents that's taught in chapter 1. Okay, and please review that if necessary before we start this class. If they look completely unfamiliar, if you remember pretty good, that is let's move on. Okay, but everything in chapter 1 you should know it like really well. Okay, to be successful in algebra and all the math after it. And so anyway, so let's get started. Okay, this is what is this? This is okay. I'm at page 619. Let's look at example 1. Okay, let me write this down. So example 1, we have a problem 2 to the x minus 1 happen to be 2 to the power 2x minus 4. Now how do we solve that? Being that the base is the same, that means if these two are the same, then the exponent has to be the same. So the next step we do is simply just say, well, the base is the same, so for the equation to be the same, then the x minus 1 is going to be equal to 2x minus 4. Equal to, okay, x minus 4. All right. So then we just solve this equation, and then we're good. Okay. And how do we solve that? Let's see. We have we'll move the x over here, become minus. It becomes x. 2x minus x, and move the 4 over here, become positive. 4 minus 1, that should be positive 3. So x equal to 3 is the answer. Okay. And that is problem 1. And then the next example on the following page, example 2. Okay, the next example, example 2 on page 620, we have 8 here, but we have 16 here. They're not the same like the first example, which was much nicer, right? There is a slight problem here. So what we're going to do is we are going to factor it into so that they have the same base. Now in this case, we can, so 8 is 2 to the power 3. Okay, so we'll do that. 8 is 2 to the power 3, and the whole thing, 8, is being, sorry, what am I saying here? 2 to the power 3. There. 8 is 2 to the power 3, okay? And that is 8 is 2 times 2 times 2. There's 3 of them multiplied. And the whole thing is being raised to x plus 2. This is important to keep track of it, okay? Because 2 to the power 3 is 8. Now, similarly, 16 is 2 to the power 4, okay? Because 2 times 2 is 4, and then times 2 is 8, times 2 is 16. So there's 4 of them multiplied together to make 16, and that is raised to the power x plus 1. And then so the next thing we're going to do, the x plus 1 is in parentheses, I guess. Is it in parentheses? No, they don't bother with it. I guess it doesn't need to be in parentheses. But we are going to follow this rule right here. That is, something raised to the power, and then the whole thing is being raised to another power, then the result is you multiply the powers together. So let's multiply 3 times x plus 2. So the next line we say, let's see, okay, 2 to the power 3 times x plus 2. Okay, this now we definitely need the parentheses because 3 is being multiplied by x plus 2, the whole thing, not just x. And then similarly, 2 to the power 4 times x plus 1 in parentheses. Okay, so at this point we have worked out problem into the same situation as problem 1, where things have the same base. Once the base is the same, then we can argue that for them to be equal, then the exponents had better be equal as well. So then 3 times x plus 2 is then equal to 4 times x plus 1. And then, yeah. And so from this point on, then we'll do the solving equations. Okay, as so we have this is so there's 4x here, 3x there. We'll subtract it, and so there's 1 left. And then this is 6, and then 6 minus 4, so that should be 2 left. And so x should be equal to 2, which it is. Okay, so that is example 2. And next, let's look at example 3. So example 3 says 2 to the 5x equal to the square root of 2. So just like example 2, we're going to make the bases the same. And so then we can say, once the base is the same, then we can say the exponents are the same and use that same trick. So for the for the base to be the same, we'll rewrite 2, okay? Square root of 2 is 2 to the power 1/2. This side doesn't change. It's still 2 to the 5 power to the x. Now the base is the same. They are both 2. Is this called base or something else? I don't care what it's called. The point is, what's being raised to the power is the same, right? It's raised to 5x. This is raised to 1/2. Well, at least they're both 2 anyway. And so that means that 5x has to be equal to 1/2 and for this equation to hold. So we have 5x equal to 1/2. And then, which means x then has to be equal to, move the 5 down, is 10. So that should be the answer, and that is correct. Wow, I'm doing great. Okay, so next let's look at example 4 on the same page, where we have 3 to the power x plus 1 is equal to -2. Now that is a non-starter because a base raised to any power is not going to be negative, okay? Because everything, when it comes to exponents, we're only dealing with positive numbers, basically. I mean, for example, you say, what if something is raised to a negative power? For example, 3 to the minus 2, that's the same, that's defined as 1 over 3 to the second power. This is taught in chapter 1, okay? Any negative power is the same as sinking it below the division line and become a fraction. But it's still positive though. You know, this is 1 over 9, still positive. So there's no way this can be -2, and therefore there's no solution to this equation. Not all equations have solutions, okay? Some equations don't make any sense and it's just not going to happen. So yeah, and let's look at the next page, page 621. Now, another way of solving an equation is if you can plot both graphs. That is, you can plot this y equal to 3x plus 1 and y equal to -2 and see where they meet. Okay, where they meet is the solution to the equation. Now, as you can see to this graph, y equal to 3 to the power x plus 1 is an exponential function that has an asymptote as on the x-axis. See, it approaches the x-axis, but it doesn't ever go past it. It just gets closer and closer to the x-axis, being the x-axis is its asymptote. Now, the line y equal to -2 is down here, and these two shall never meet. Okay, so they're never going to cross, and therefore there is no solution that satisfies both conditions, and they have the cross for that. So that's that. And next, let's look at example 5. Let me write it down. Okay, now example 5, when you look at it, there's number 5 raised to the power x plus 2, and then number 4 raised to the power x. Now we have a problem because 5, there is for example, in this problem, this is example 2, we have 8 raised to some power 16, and we were able to reduce it by factoring so that it becomes the same base. Both sides then later become 2, right? Same base. So we are able to get around this way. However, this one, there's no direct, we're not going to factor this thing into the same thing. Okay, I mean not directly anyway. So now what? Now we're going to pull the trick. And the trick is called the logarithm. We're going to pull this trick right here, okay, this thing. And the way we're going to do it, we're going to slap the word log in front of both equations. Now, your book decided to use the natural log, which is fine. And that's as good as any. But you can use any log. Doesn't matter what base it is. It will work. So to be the same as the book, we will use the natural log. So let's slap the natural log on both sides of the equation. If you do something to both sides, then you have not changed the equality. Okay, they should be the same. So we'll put natural log 4 to the power x, and so on. Now, the reason of doing this is to use this rule right here, because then we can kick the exponent down, right? And that's what we're going to do. Well, so this becomes x plus 2 is now down here. Let's put it in parentheses. Okay, natural log of 5 equals to x goes in front, x natural log of 4, and we're following this rule right here. The fact that the exponent is x plus 2 changes nothing. Okay, and it doesn't matter what's up here, you can kick the whole thing down, the entire chunk in parentheses, kick it right in front, and then so now we're good. Now at this point, remember, what is ln5? It's a number, okay? You can punch it in the calculator and it'll tell you something. It might be equal to, I don't know, 2 point something maybe, who knows. And similarly, natural log 4 is some other number. It might be 1 point something, I don't know. If we punch it in, we'll find out, but we're not going to do that right now. The point is, this is a number like 2, and that's a number like, 3 or something, doesn't matter. No, it wouldn't be 3 if this is 2. Let's say this is 3, and similar to 3, and that's similar to 2. And then you can solve this equation. The same way you would solve it if this were 3 and this was 2, okay? And to solve this equation, we do it like we always solve it. We have, so we'll move this thing over here and multiply stuff out. Then first let's multiply it out, I guess. So then we have x times natural log of 5, okay, that's the number, and times x, plus 2 times natural log of 5, 2 ln please, this is bent, 2 times natural log of 5, so 2 ln of 5, and then I'll move this thing to this side of the equation. It becomes minus, so x ln of 4, and that will be equal to 0. Now if that is the case, we're gonna combine the things that has x's in it, okay? Right, so that would be ln 5 minus ln 4 times x will be equal to, move this to the other side of the equation, equal to minus 2 ln of 5. All right, so what is x then? In that case, then x will be equal to, I'll write the answer up here. So I'm going to write the answer to this thing up here, okay? That means you take this whole chunk and push it down here below the division line. So x equal to, over here is negative 2 ln 5, and divided by natural log of 5, ln 5 minus ln 4. And that should be the answer to this problem. So let's check what the book says. Oops, it turned. X equal to, yes, natural log 5 minus natural log of 4, and minus 2 natural log of 5. That is the answer in the book. Now, there's more than one way to solve an equation, okay? And so, the answer in the book might sometimes can look slightly different, but it works the same principle. Now, you say, well, but the answer in the book, is that the answer? Let me see, maybe they go to the next page. No, they don't. This is it. They just leave the answer like that. Okay, but let's show why this answer is the same as the answer in the book, okay? And so this is to make it look exactly like the answer in the book. Now, this is negative 2 is in front, right? And we'll push it up here again. So we'll push negative 2 to on top of 5. So this is equal to natural log of 5's negative 2. All right, divided by, and then this is a subtraction, right? Natural log of 5 and natural log of 4. And subtraction means what? Subtraction means division if you combine them. So this is the same as natural log of 5 divided by 4. Okay, and in the meantime, this on top, this numerator is also equal to negative power is the same as 1 over that thing. Okay, 5 to the minus 2 is the same as 1 over 5 squared. And 1 over 5 squared is 25, which is why the book has the answer that it does. Let's see, I lost it. Where did it go? What example is this for? Okay, here we are. Right, so as you can see the book's answer, which is right here. Okay, and that is why that answer is actually identical to what I found. And that's example 5. All right. So next, let's look at the next example, example 6. Okay, next let's look at example 6 on page 622, where we have 100 equal to 20 times e to t. All right, and we need to solve for t is the point. Now to do that, first we will we'll get rid of the 20. Our goal is to isolate t, so let's get rid of the 20, okay? And by pushing it down here, so that would be 100 divided by 20, that's 5. So that's fine. But the question is, now we have e to t, and now what? Okay. Now, so at this point, we're going to first remember what is the natural log. The natural log is the same. The natural log is the same. The regular log base e. Okay. It has a special name. Log with a base e is called the natural log. So what we're going to do is we're going to pull this trick. Let's see which one right here. We're going to slap this trick right here. Okay, and what we're going to do is, this is e, so we're going to slap the natural log on both sides of the equation. So we have ln, let's see, natural log of 5, okay, and that is equal to natural log of e to t. Okay, that's fine, and what about it? Well, the natural log being is, which means log base e. Okay, so natural log is basically has a base e here, which means this number and that number is the same thing. Now, if the bases are the same, the log of b to the log base b of b to the power x is x itself. In other words, what this thing, okay, we have e and e here. This is the same as 2t. See, that is the fantastic trick. That's why we slap specifically the natural log, because there's an e here. Basically, what it does is the natural log and the e cancels out. Okay, they're inverse functions, and then so you got just 2t left. How neat, right? And so we have so that means, so now this equation is a piece of cake because we only have 2t left. Then t is equal to so t is equal to natural log 5 divided by 2. So ln 5 divided by 2. All right, so that should be the answer. Let's see, does the book say that? Yep, it does. All right, so next let's look at example 7 on the same page at the bottom. So in example 7, we have 4e to x plus 5 equals to 12, and we need to find x. So let's do it the same way we solve all equations. And that is, we're zooming in for x, right? So we're going to get rid of everything that isn't x and throw it to the other side of the equation. First, get rid of 5. So that would become, when the 5 is over here, that means 12 minus 5, that is 7. Okay? And secondly, then we have 4e to x left. And then I'll write it down, I guess. So 4e to the power 2x is then equal to 7. Next, we push the 4 down, so we have e to the power 2x now is equal to 7 over 4. All right, and finally, we need to use the natural log trick, because the base is e here, and then so it's raised to the power of something. And to get rid of it, we're going to slap the natural log in front, because it cancels out this thing according to this rule. See, if they're the same, then you just all these disappears, and you end up with just whatever's on top. See, and so that's what we're going to do. Let's slap natural log on both sides of the equation. So then, so natural log of e to the power 2x equal to 7 over 4. And the natural log of e is the same as log base e to the e, so that disappears. And we only have 2x left. Okay, so then 2x equal to 7 over 4. That means x equal to, push the 2 down here, it's x equal to 7 over 8. And that is the answer. Okay, now let's see what the book says. Turn to the next page. Let me see. E2x is 7 over 4. 2x, oh, sorry. I forgot to do something. I forgot to put the natural log here. All right. Okay. Now, yeah, see? I put the natural log here, but I forgot to put it in front here too. You have to do it for both sides to be fair, right? I mean, otherwise, how did that suddenly become 7 over 4? Okay, so that is, let's put the natural log here. So this equals the natural log of 7 over 4. That's much better. natural log of 7 over 4. Okay, so that is equal to 2x. So x then equal to, just push the 2 under this whole deal. Okay, and let's see, I'll write it. Yeah, so x equal to, I'll write it the way the book write it, which is 1/2. Okay, so the 2 is under the division line, and natural log of 7 over 4. This in parentheses, and that is the answer. Okay, you can putting things in the, when you push it down the division line, the 2 can go completely under natural log, or just as a 1/2. The same, it's the same thing. Okay, so either way, that is the right answer. So that is the end of part A. We'll do the rest of it in the next video. So, but this video will have its own set of homework. Okay, so that so right now we will look at the homework. Actually, let's do one more example, because the example 8 is the same thing. Okay, some kind of a equation with e in it. So let's do example 8 on page page 623. Now example 8, example 8, we have e to the power 2x and e to the power x. Now that is a bit weird, right? Because before we just have one e, and now there's 2 of them. But in this case, it happens to be in a convenient form. That is, let's allow y equal to e to the power x. Okay, so let y equal to e to the power x. Then this equation transforms into y squared minus y minus 56 equal to 0. All right, and then we'll solve for y, and once we figure out what y is, then we'll solve for x from this equation. So to solve for y, we do that same old trick, okay? And we need to something multiplied together to be 56, and that their difference has to be -1. So that will be 7 times 8, with 8 being negative, okay, and 7 being positive. And then we have y here, and that's about it, right? So as a result, y from this solution, y is either equal to -7 or y equal to +8. Now, being that y equal to e to the power x, it is always positive, okay? So this is rejected. So this is rejected. This is rejected. And then y to the 8 is the only one we can allow, because there's no way e to the power x is going to be negative. So e to the x is equals e to the x equal to 8. All right, so and now we need to solve this thing, and just like before, to solve e equal to something, we slap the natural log in front of it. It's the on both sides. It's the standard trick. That is, so let's slap the natural log on both sides. Okay, don't make my mistake of forgetting to put it on the other side. It should be both sides, to be fair. Okay, and then so let's so that becomes natural log e to the power x equal to natural log of 8. Now, natural log and e are inverse functions, okay, because natural log is the same as log with base e. And anytime you have e and e, then this thing just becomes whatever's on top, see? And so this is the same as x. So that means the answer is x is natural log of 8, which is correct, okay, in example 8. So now let's go look at the homework. So for homework, please do page 628 for this part 8 of the section, okay? And please do problems 5, 7, 9, 11, 13, 15, 17, 19, 23, 25, 27, 29, 31, 33, and 35. And that is also in the video description. And then and then in the next video, I will go over the homework and go over some of the problems, and then continue the second, the part B of this section.